Hello! Kamusta kayong lahat? Tom at Jenny nga pala ang inyong tropang estudyante. Ngayon, kasama natin ng ating professor upang turuan naman tayo mag-calculate ng derivatives gamit ang 4 na rules. So, simulan na natin, Professor!
Calculation of derivatives. We'll learn the power rule, the product rule, the reciprocal rule, and the quotient rule for finding derivatives. We begin by noting the derivatives of a few basic functions. First, any constant function f of x equals c has derivative f prime of x equals 0. Just think of the graph of a constant function that is a horizontal line which always has slope 0. The identity function f of x equals x has the derivative f prime of x equals 1. Again, just think of the graph of y equals x, which is a straight line which always has slope 1. The power rule. If n is a positive integer, then the function f of x equals x to the nth power has derivative f prime of x equals n times x to the n minus 1. In other words, to find the derivative f prime, simply multiply by the power and reduce the power by 1. For example, the derivative of x squared is 2x to the first power. The derivative of x to the fifth is 5x to the fourth power. Now let's try to see why the power rule works. The difference quotient for x to the nth power is x plus h to the n minus x to the n divided by h. We can expand the first term here using the binomial theorem, obtaining x to the nth power plus remaining terms, each of which has at least one factor of h. Notice we have x to the n minus x to the n, so all the remaining terms in the numerator involve at least one factor of h. And so we can divide h into each of those terms, and the first term we have is n times x to the n minus 1, and all of the other terms still involve at least one factor of h. Therefore, as h goes to 0, we are left with only the first term, n times x to the n minus 1. Linearity properties. The derivative of the function f plus g is f prime plus g prime. In other words, the derivative of a sum is the sum of the derivatives. To see why this is true, let's look at the difference quotient for f plus g. F of x plus h plus g of x plus h minus f of x plus g of x all divided by h. Now we simply rearrange terms here in the numerator and then split up into two fractions. We simply have the sum of the difference quotients for f and g. Therefore, as h goes to 0, we obtain f prime of x plus g prime of x. 2. The derivative of a constant times f is the constant times the derivative of f. To see why this is true, just look at the difference quotient for c times f. C times f of x plus h minus c times f of x divided by h. And notice that we can factor out a c, and we simply have c times the difference quotient for f, which approaches c times f prime of x as h goes to 0. For example, if f of x is x squared plus x cubed, then f prime of x can be computed by simply taking the derivative term by term. The derivative of x squared is 2x, and the derivative of x cubed is 3x squared using the power rule. So the derivative of x squared plus x cubed is 2x plus 3x squared. The derivative of 3x to the fourth is simply 3 times the derivative of x to the fourth, which is 3 times 4x cubed, or 12x cubed. Here's an example that combines both rules. The derivative of 3x squared minus x is 3 times the derivative of x squared minus the derivative of x, or 6x minus 1. Example. Let's find p prime of x if p of x is the polynomial x to the fifth plus 2x cubed minus 5x squared plus 3x plus 2. We'll find p prime by simply taking the derivative of p term by term. The derivative of x to the fifth is 5x to the fourth. Then we add 2 times the derivative of x cubed, which is 3x squared, and then minus 5 times the derivative of x squared, which is 2x, and plus 3 times the derivative of x, which is 1, and then plus the derivative of 2, which is 0. And so this simplifies, as you see here, 5x to the fourth plus 6x squared minus 10x plus 3. Another example. Let p of x equal 2x cubed minus 3x squared minus 12x plus 5. We want to find all x where p prime of x is positive and all x where p prime of x is negative. We'll first calculate the derivative. It's 2 times the derivative of x cubed, which is 3x squared, minus 3 times the derivative of x squared, which is 2x, minus 12 times the derivative of x, which is 1, plus the derivative of 5, which is 0. So we have 6x squared minus 6x minus 12. Now, since we want to know where this is positive and negative, we'll factor, first factoring out the common factor 6, and then factoring x squared minus x minus 2 into x plus 1 times x minus 2. So we can see that the derivative p prime of x is 0 at x equals minus 1 and x equals 2. Moreover, p prime of x is negative when x is between minus 1 and 2. Think of the graph of the quadratic function here. It's a parabola that opens upward, so it must be negative between its two zeros. And p prime of x is positive for x less than minus 1, as well as for x greater than 2. Now let's think about what this means in terms of the graph of the function p of x. Notice that the graph of p of x has positive slope when x is less than minus 1, negative slope when x is between minus 1 and 2, and positive slope when x is greater than 2. And this is exactly what we learned from determining where the derivative is positive and where the derivative is negative. Here's another derivative of a basic function. The square root function f of x equals square root of x has derivative f prime of x equals 1 over 2 times the square root of x. This is a straightforward calculation. Let's look at the difference quotient, the square root of x plus h minus the square root of x divided by h. We multiply the top and bottom of this fraction by the square root of x plus h plus the square root of x. Multiplying out the two numerators, we obtain x plus h minus x, or simply h, and now we can cancel an h to obtain 1 over the square root of x plus h plus the square root of x. And clearly, as h goes to 0, this quotient approaches 1 over 2 times the square root of x, for all positive x, of course. Example. Let's find and simplify f prime of x if f of x is 3 times the square root of x minus x squared. We'll first write the derivative of the first term, which will be 3 times the derivative of the square root of x, or 3 times 1 over 2 times the square root of x, and then the second term gives us minus 2x using the power rule. Now simplification here will essentially be a matter of combining the two terms together over a common denominator. To do that, we multiply the second term by 2 times the square root of x over 2 times the square root of x, and now combining the terms gives us 3 minus 4x times the square root of x divided by 2 times the square root of x. The product rule. The derivative of a product f times g is the derivative of f times g plus f times the derivative of g. For example, the derivative of x times the square root of x is the derivative of x, which is 1, times the square root of x, plus x times the derivative of the square root of x. Simplifying, we obtain the square root of x plus 1/2 the square root of x, or 3/2 the square root of x. Now let's see if we can see why the product rule is true. The difference quotient for f of x times g of x is f of x plus h times g of x plus h minus f of x times g of x, all divided by h. Now we use a little bit of trickery here. We'll make some space between the terms in the numerator and subtract f of x times g of x plus h and add the same term. Now we group the first two terms and the last two terms together and factor g of x plus h from the first two terms in the numerator and factor f of x from the last two terms in the numerator. Now we break the fraction apart into two terms. The first term is the difference quotient for f times g of x plus h. The second term is f of x times the difference quotient for g. Now as h goes to 0, first term approaches f prime of x times g of x, and the second term approaches f of x times g prime of x. Example. Let f of x equal x squared minus 1 times the square root of x. Find and simplify f prime of x. So we apply the product rule here. F prime of x would be the derivative of x squared minus 1, or 2x minus 0, times the square root of x, plus the first factor, x squared minus 1, times the derivative of the second factor, 1 over 2 times the square root of x. So the first term is just 2x times the square root of x. The second term is x squared minus 1 divided by 2 square root of x. Now we multiply the first term by 2 times the square root of x over 2 times the square root of x to obtain a common denominator. And now the first term is 4x squared over 2 times the square root of x. And now adding, we obtain 5x squared minus 1 divided by 2 times the square root of x. Example. Let f of x equal the product of two polynomials, x squared minus x times x cubed plus x squared minus x plus 1. And let's find f prime of 1. Now we'll use the product rule to calculate the derivative. F prime of x equals the derivative of the first factor, 2x minus 1, times the second factor, plus the first factor, times the derivative of the second factor, which is 3x squared plus 2x minus 1 plus 0. Now, since we only want to know f prime of 1, we may as well simply plug in x equals 1 and just do the calculation. The final result here is 2. Example. Let f of x equal the square of x cubed plus x minus 3. Find and simplify f prime of x. To use the product rule here, we'll write f of x as x cubed plus x minus 3 times itself. Now f prime is the derivative of the first factor, 3x squared plus 1, times the second factor, plus the first factor times the derivative of the second factor, which is again 3x squared plus 1. So we have two identical terms here, and so f prime of x is 2 times x cubed plus x minus 3 times 3x squared plus 1. Example. Let f of x equal the square of the function g of x. Let's find f prime of x in terms of g of x and g prime of x. And notice that the previous example is just a special case of this. Just as before, we'll write f of x as g of x times g of x and use the product rule. The derivative of the first factor, g prime of x times the second, g of x, plus the first factor times the derivative of the second factor. Again, both terms are the same, and so we have 2 times g of x times g prime of x, which is exactly the form of the result in the previous example.
Yun lang po muna mga tropa. Please subscribe and watch out for the part 2 of our video.